Hi, this is the second video for section 6.6. It's just the one on kites. So this one should be a little shorter than the last one. So our last shape of this chapter is the kite. The kite looks like a kite, so it's easy to kind of keep track of it. Its definition though is a bit wordy. It's a quadrilateral with exactly two pairs of consecutive congruent sides. And one of the other parts of it that the book throws in here is the fact that the opposite sides of a kite are not parallel, nor are they congruent. So, our old textbook actually used to define it as a quadrilateral with two pairs of congruent sides where opposite sides are not congruent. Our new textbook goes with exactly two pairs of consecutive sides. So PS, SR consecutive, PQ, QR consecutive, those are congruent. To be honest, I'll take either one and I'll probably use both in class, so I apologize. It's kind of hard to break old habits. When that happens though, it brings up some interesting properties for the kite. First of all, if it's a kite, the diagonals are perpendicular, which if you kind of think about it, if you've ever flown a real kite before in this kind of shape, the braces for it always make a right angle in the middle. This is also like the rhombus and the square, but again, it's not a rhombus or a square because it's not a parallelogram. The second theorem that's can be more confusing to use is that if you have a kite, exactly one pair of opposite angles is congruent. Not two pairs, but one pair. And it's the pair that's formed by the two non-congruent sides meeting. That's what ends up happening. So the trick is to know which pair of angles are congruent. And again, it's not the ones that are formed by the consecutive congruent sides. K and M are formed by those two congruent sides. Not going to be congruent to the angles then. But the ones formed by the non-congruent sides meeting, L and J, they are congruent. Okay. So example problems. Let's see, 24 and 25. 24, you're trying to find the length of YZ. The real trick to this problem is using some geometry that the book assumes you know, treats you like you don't know it, because then we learn it later on in second semester. But what we're really going to use is the fact that this guy ends up being a right triangle, because the diagonals are perpendicular. So I get this right triangle here with side lengths of 8 and 5. And, whoops, I did it the wrong side, didn't I? I'm looking for YZ. Doesn't really matter, it's the same thing. Here's one leg of the right triangle. This is the other leg, and then YZ is the hypotenuse. Now, the diagonals, this isn't one of our theorems per se, but the diagonals do get bisected on the one that's between the two non-congruent sides. So W to here is not the same as from here to Y, but X to the middle and the middle to Z, they are both 5. And it's not a theorem, it probably kind of should be, but it's not one of our theorems we use in class. So this segment here is congruent to this segment. So what we're going to use is the Pythagorean theorem to do this. So ZY is the hypotenuse, or YZ, excuse me. And then so I'll set up my right triangle. Okay. So 5 squared plus 8 squared will equal C squared. For right now, we get to be really kind of lazy. 5 squared is 25. 8 squared is 64. So this ends up being 89 equals C squared. We'll take the square root to solve, and we'll keep the primary root because we don't care about the negative length because it's a length, so it can't be negative. Later on in the year, we'd have to check and see if root 89 simplifies, but at this point, we can just leave it as root 89. So that's the length of YZ in this case, because YZ is equal to C, so it's equal to root 89. Now, number, what's the next one? Number 26. They're wanting us to solve for the measure of angle x. Okay. Well, when we draw that figure out, we have w, we have x, we have y, we have z. And they give us the pair that wx and wz are congruent, and zy and xy are congruent. And they want us to find the measure of angle x. And they tell us that angle W is 70 and angle Y is 56. So here's the drawing we're looking at, primarily. So in order to do this one, we actually have to use two properties. One is that the non consecutive sides meet to form congruent opposite angles. So one pair of opposite angles are congruent. Luckily for us, that is what we're looking for. So I'm looking for the measure of angle x. So I can just call this guy x, and since that's congruent, that's also x. Now, looking at that, you might say, well, great, it doesn't give me any more help. I still don't know x, but it is a quadrilateral, so all four angles add to be 360. So 70 plus x plus 56 plus x is 360. And now we just add like terms. X plus x is 2x. 70 plus 56 is 126. We'll subtract 126. 2x is equal to 234. Divide by 2. Running out of space here, sorry. X equals 117. And that's actually the measure of angle x as well, which is what we wanted to know. Now I think I only have one more problem to really look at for the kite, because there isn't nearly as much in this section, this part of the section. Yeah, so we'll look at number 50. So for number 50, we have the drawing given to us there, which is kite WXYZ. And I'm going to tell you right now, when I go to the next screen and you see a look at this kite, it's terrible. I apologize, but I don't feel like fixing it. It's only there for a guide anyway. So measure of angle WXY is 13x plus 24. Measure of angle WZY is 35. Okay. Measure of angle ZWX is 13x plus 14. Now this problem is kind of irritating because the book does something they really shouldn't do. And they normally don't do this, but for some reason they decided it's okay in this problem. But we have to make an assumption that one of those pairs of angles is congruent. And we really don't know which one technically is because they didn't mark the congruent sides. But we do get to use our eyes and say, oh, it's probably this angle and this angle, because those two sides are not congruent. So that's the pair of congruent angles. So really what we're back to then is the last problem with just some more complicated algebra. So here's the drawing. Here's what we know. Again, this angle's 35. This angle's 13x plus 24. This angle's 13x plus 14. Did I write that down right? That seems weird. Yep, both 13x. Okay, and so this means this angle here is congruent to W, so that's also 13x plus 14. So now what we will do is just add up all four angles and again set it equal to 360. So 13x plus 14 plus 13x plus 24 plus 13x plus 14 plus 35 has to equal 360. So 14 plus 24 is 38, plus 14 is 52, plus 35 is 87. Okay. 13 plus 13 plus 13 is 39x. So 39x plus 87 is 360. So subtract 87. 39x ends up being 273. Divide by 39. I think that's something like, I don't know, 7 or something. Let's just see. Make sure my arithmetic is right. Bring up my calculator. Sorry, that's other stuff for calculus. And that's my family. Alright, here, so let's see, 273 divided by 39. Yep, 7. Okay, and let's see, now the actual problem, though, calls for us to find the measure of angle ZYX. Well, ZYX is the same thing as WXY, so 13 times 7 plus 14, that ends up giving us 13 times 7 plus 14 is 105 degrees. And there we go. So, again, I apologize. Both these are kind of long total, but that's kites and that's trapezoids.